So in this example, we have this probability distribution. Our first table is probability distribution. Okay, we have our x discrete random variable. We have the probability that x takes this number is given to us. So this table is a probability distribution for us. And we have the second table. Okay, and in second table we have this x is observed twice. Okay, so our x takes number 1 2 3 4 5. So x takes number 1 2 3 4 5, and if we observe x twice, then these will be our samples. Okay, we might observe 1 1 1 2 1 3 1 4. So all these are the sample for us. Okay, so our x is taking 5 number 1 2 3 4 5, and if we observe x twice, so the possible sample we get here is, so these are the possible sample that we get. And for each sample we have the probability. Okay, so for example, the probability of observing 2 and 2 is 0.09. The probability of observing 4 and 3 is 0.04. So we have this second table with sample and its probability. In the first part, we are asked to create a sampling distribution of this sample mean x bar. So at first what we did, we calculated the x bar for each sample, right? So we have x bar for each sample. Okay, now the next we need to find the probability that x bar takes this number. So our x bar takes 1 1.5 2 2.5 3 3.5 4 4.5 and 5. Okay, this is what we know. The next we have to find the probability that x bar takes this number. Okay, now we are at 2.5. So what is the probability that x bar takes 2.5? So let's find 2.5 x bar. So 2.5 is here. So we have here 2.5, here, here, right? So we have 1 2 3 4. So we have 2.5 here. Now what will be the total probability? It is the sum of these 4. Okay, so we have 0.04 plus 0.06, which is 0.1 plus 0.06, that makes 0.16 plus 0.04, that makes 0.2, right? So the probability that x bar is 2.5 is 0.2. Okay, now the next, let's find the probability that x bar takes a number 3. Now we look for the x bar value 3. So we have here 3, we have 3 here, we have 3 here, we have 3 here, we have 3 here. So what will be the probability that x bar is 3? Now let's go ahead and add these probabilities. So this is 0.02 plus 0.06, that makes 0.08, plus this 0.08 plus 0.04, that is 0.12, plus 0.06, that makes 0.18, plus 0.02, that makes 0.2. Just correct me, okay, if you have something different here. So the probability that x bar is 3 is equals to 0.2. Now let's find the probability that x bar takes a value 3.5. So we are looking at x bar value equals to 3.5. Let's see where we have 3.5. So we have 3.5 here, we have 3.5 here, we have 3.5 here, we have 3.5 here, and the probability that x bar is 3.5 is equals to, so 3.5, so 0.03 plus 0.04, which is 0.07, plus this probability, that is 0.11, plus this probability 0.12. 0.14. So the probability that x bar is 3.5 is 0.14. Now the next we have x bar equals to 4. So we look at the probability. Okay, we look at for x bar equals to 4. Now let's see where do we find 4. Okay, 4. Okay, we don't have 4 here. We have 4 here. We have 4 here. We have 4 here. So the probability is 0.02 plus 0.04, which is 0.06 plus 0.02, which is 0.08. Now let's find the probability that x bar takes 4.5. So let's see where is 4.5. 4.5. So we have 4.5 here and we have here. So we have 4.5. So the probability that x bar is 4.5 is 0.02 plus 0.02, which is 0.04. Now the next one, the probability that x bar is 5. So we have 5 only here. So the probability is 0.01. 0.01. So this is our sampling distribution. Okay, so this is the sampling distribution for our statistics x bar. Now, how are we gonna know whether this distribution is correct or not? So how are we gonna check whether this is correct or not? All the numbers. Yes, the sum of all these. The sum of all these probabilities has to be equals to 1. Okay, so let's see. So 0.04 plus 0.12, that is 0.16 plus 0.17, that is 0.33 plus 0.2, that is 0.53, then 7.87, 0.95. I think it's 1. We get 1. So if we add all of these probabilities, the sum has to be equals to 1. So we have this sampling distribution. Okay, now does anyone have any question here? You will have a very similar question on your exam. Okay, so make sure you understand here. Now the next part, we are asked to construct a probability histogram for the sampling distribution of x bar. Now we have this sampling distribution for x bar and we need to create a histogram. So for B, so histogram, so we have the horizontal axis for x bar. So this is our x bar and this is our P of x bar. So we create a histogram for this table. Okay, now let's write down the values of x bar. So x bar takes a value 1, it takes a value 1.5, it takes a value 2, it takes a value 2.5, it takes a value 3, it takes a value 3.5, 4, 4.5 and 5. Now in the histogram we need to draw a bar. Now what gives us the height of a bar? How do we know what height of a bar we draw at 1? What is that height? How do we know the height of a bar at x bar equals to 1? It is equals to the probability that x bar takes 1, right? So which is 0.04. Okay, so let's make it, so we have 0. So let's say this is 0. Okay, now 0.5, this is 0.1, this is 0.15, this is 0.2. I think it should be enough. So at 1 we draw a bar of a height 0.04. That's 0.04. Where is our 0.04? So this is 0.5. Okay. So this is 0.05. Okay, now what we can do next is that we can just rewrite our probability in terms of percentage. Okay, so let's convert this probability in terms of percentage. so that it will be easier for us to have a scale here. Okay, so 0.04 means that is 4%, right? 0.12 means that's 12%, that is 17%, that is 20%, 20%, 14%, 8%, 4%, 1%. Now, so let's let's call this is that is 10, 20, 30. Okay, or let's do 5, so let's call this is 5, 10, 15, 20. So the minimum is 1% and the maximum we have 20, so I think it should be enough. Now let's draw a bar. So at 1 we draw a bar of a height 4%. So this is 5, so 4 is just below 5. Okay. Now 1.5, the probability that x bar takes a value 1.5 is 12. So this is 10, 12 is just above 10. Now the probability that x bar takes a value 2 is 17%. So this is 15, 16, 17, somewhere here. Now 2.5 is 20%. So here 3 to 20%. 3.5, 14%. So this is 15, just below 15. We draw a bar. 4, that is 8%. So this is 5, somewhere here. 4.5, 4%. 5, 1%. This is the histogram. Does anyone have any question for part B? Okay, the next one, what is the probability? Now for part C, what is the probability? What is the probability that x bar is 4.5 or larger? So that is greater than or equals to 4.5. Okay, bless you. So we are asked to find the probability that x bar takes 4.5 or greater than 4.5. Now what values do we have for x bar which is equals to 4.5 and greater than 4.5? So what are the values we have in the table? So we are looking at the x bar which is equals to 4.5 or greater than 4.5. So what do we have for the values of x bar with this 4.5 and 5, right? So this is equals to probability that x bar is equals to 4.5 plus probability x bar equals to 5. So from the distribution table, what is the probability that x bar is 4.5? That is 0.04 plus the probability that x bar is 5, which is equals to 0.01, and this is equals to 0.05. So 5% is the probability that x bar takes a value 4.5 or greater than 4.5. Okay, any question? Make sure to take the picture of this activity and upload on your Canvas, okay? Now let's go ahead and start our new section, chapter 6.2. Okay, in section 6.1, we started our sampling distribution. Okay, so here in this chapter we are trying to learn how to make a estimation of our parameter. Okay, and to make a estimation of a parameter, what do we use? What do we need? how do we make an estimation of our parameter? We need a sample, right? And from sample, what do we calculate? We calculate statistic. And with the help of a statistic, we make an estimate of a parameter, okay? And statistic means, what are the statistic? Statistic are, can you give me examples of statistic? X bar. Is it mu? No, mu is not a statistic. M, which is median, right? S square, which is variance of a sample. S, standard deviation of a sample. Okay. In the similar way, parameter are mu, which is a mean of a population. Sigma, standard deviation of a population. Sigma square, variance of a population. Okay. So with the help of statistic, we calculate or we estimate our parameter. Now, so now here in section 2.2, we will talk about the properties of sampling distribution, okay? So let's, for example, we have a sample. Let's take a sample here. So for example, this is our sample, okay? From this sample, we calculate, what do we call a number that we calculate from sample? We calculate statistic, right? So from the sample, we have the statistic. Okay, so statistic means, so here we have X bar, or we calculate median, S square, S, okay? And these are the single values, right? So X bar is a single value for a sample. M is a single value for a sample, okay? And we use this statistic that we get from a sample to make an estimation of a population. Population is always big size, right? So this is our population, okay? So we have a sample, we calculate this statistic. It means we calculate X bar, median, S square, S, okay? And we use this statistic to make a estimation of a parameter. So parameter means we make a estimation of a mu or eta, median, sigma square, variance, sigma, okay? There is a p hat for a statistic. We have a sample, we calculate the statistic are a single value, okay, and we use this single value to make an estimate of a parameter, okay? So parameter are the number to represent population, okay? Now this rule or this process, we call it here is a point estimator, okay? So here our point estimator is a rule, or it can be a formula that tells us how to use a sample data to calculate a single number. So we have a sample data here, okay? This rule tells us how to use this sample data to calculate single number. Calculate single number means calculate X bar, median, S square, S, p hat, and that can be used as an estimate of a population parameter, okay? So we calculate this single number and we use this single number to make an estimate of this parameter, and this rule is a point estimator, okay? So you have a sample, okay? This from the sample we calculate the statistic and use that statistic to make an estimate of population parameter, okay? And the rule that tells this process is our point estimator. So point estimator is a, so for example, for a parameter mu, so for parameter mu, X bar is a point estimator, or it can be median, okay? So point estimator is a statistic, okay? And we use this point estimator to estimate parameter. Okay, now here we have an example. Suppose two statistics A and B exist to estimate the same population parameter theta, okay? So here we have a two statistics A and B. Now, two statistics A and B means A and B can be X bar, median, S square, S, p hat, okay? Do not get confused. So here the option for A and B. So A and B can be X bar, it can be M, it can be S square, S or P hat. So we have two statistics out of these statistics, okay, and these two statistics estimate our population parameter, and let's call it theta, okay, and theta can be mu, sigma square, sigma P, okay. So we have two statistics A, B, and these two statistics A, B are used to estimate the population parameter theta. And we have this smooth curve, okay. Smooth curve means we have this sampling distribution, okay. Now for this smooth curve, how we know this is a sampling distribution? So we have this smooth curve. This smooth curve can be a probability distribution, it can be a sampling distribution. Now how do we know these two curve is a sampling distribution? Right, so we have C, the horizontal axis is A, the horizontal axis is B, okay. If your variable is statistic, then that is sampling distribution, okay. Instead of A and B, if it was X, then it is probability distribution for a continuous random variable. So we have this sampling distribution, and on the basis of this sampling distribution, we have to find which statistic is more attractive or is best estimator of theta. Now, so here, this point is the mean of a sampling distribution, okay. So this sampling distribution has a mean, so this middle point is the mean here. Okay, now out of these two sampling distribution, which sampling distribution would be the good estimator of theta here? Okay, now why it is A and why it is not B? So this theta, so theta is your parameter, okay. So for the first distribution, your mean of a sampling distribution and a theta is at the same point. In the second statistic, in second sampling distribution, so this point is the mean of a sampling distribution and our parameter is over here. So for any sampling distribution to be a best estimator, what we want our sampling distribution to be around the mean of a sampling distribution, okay. So we want our distribution center at the parameter. So we have this distribution, okay. So this is the distribution. So this is our distribution for a sample. Okay, this is sampling distribution, and this sampling distribution is center to our parameter theta in first case. In second case, is the sampling distribution center to our parameter theta? So our theta is all the way to the left, right? So out of these two sampling distribution, the sampling distribution for a statistic A is the best estimator. So we always look at sampling distribution that center to our parameter, okay. So this is one of the way to find out the best estimator. So you always look for the sampling distribution that center at the parameter. Okay, now, so the estimators are of can be unbiased or a biased estimator, okay. So if we have if the sampling distribution of a statistic theta hat has a mean equals to a population parameter theta, like the very first statistic. So here in this sampling distribution, our mean of a sampling distribution is here, okay. So mean of this sampling distribution is at this point, and this mean of a sampling distribution is equals to our parameter theta. So we have a sampling distribution. If the mean of a sampling distribution is same as our parameter, we call that statistic as a unbiased estimator, okay. So our the first picture is unbiased sampling statistic for parameter theta. Now, if the mean of a sampling distribution is not equals to parameter, the statistic is said to be biased estimator of the parameter. Like in the second example, so here, so our mean, so this is a sampling distribution. Sampling distribution has a mean here, okay, so this point is the mean of a sampling distribution, but our parameter is somewhere here on the left of mean. So the mean of a sampling distribution is not equals to our parameter. Okay, so if we have the statistic where the mean of a sampling distribution is not equals to parameter, we call it biased estimator. Okay, but if the mean of a sampling distribution is same as a parameter, we call it unbiased estimator. Okay, now here we have a sampling distribution for two unbiased estimator. Okay, now how do we know? Okay, these two are unbiased estimator. To be unbiased estimator, what we need? The mean of our sampling distribution has to be equals to our parameter. Okay, so for example, so if we are talking about parameter mu, if we are estimating our parameter mu, so this is our distribution. So we have this distribution. Okay, this distribution has a mean at this point. Okay, and we have our second so this is our next sampling distribution. Okay, this distribution also has a mean at the same point. So mean is at the same point. So we have a two sampling distribution with exactly same mean. Okay, and this our parameter mu is also at the same point. So let's take two sampling distribution whose mean is equals to parameter mu. Now, out of these two sampling distribution, we need to find out the best estimator. Now, which one is the best estimator out of sampling distribution of for statistic A or B? Now, they both are unbiased estimator. Okay, why they are unbiased estimator? Because the mean of a sampling distribution for A and B is equals to our parameter mu. Okay, so these are unbiased estimator. Now we have to find the best out of A and B. Okay, why A is the best estimator? Because it has less standard deviation, right? So our distribution A is less spread. Okay, we always want our sampling distribution to be less spread. It means we always want sampling distribution with a small standard deviation. So we always pick a sampling distribution which is unbiased and has a less standard deviation. So the sampling distribution with a less standard deviation and unbiased estimator is the best estimator for our parameter. Okay, now we have an example here. We have these three different tables. Our first table is probability distribution, right? So our x takes a value -5, and the probability that x takes a value -5 is 1/9. X takes a value 0, and the probability that x takes a value 0 is 6/9. X also takes a value 5, and the probability that x takes a value 5 is 2/9. The next second table is the sampling distribution of a x bar. So this table is a sampling distribution of x bar, and the third table is a sampling distribution of median m. Now the first question here is, we need to show x bar is an unbiased estimator of mu. Okay, now what does it mean by unbiased estimator of a mu? So to be unbiased estimator, what do we need? So to be unbiased estimator, what do we need? the x bar of a distribution. Okay, so x bar, or let me just use mean of a sampling distribution, mean of a sampling distribution, it has to be equals to parameter. Okay, in general it can be mu, it can be sigma. Right now let me write down parameter. So you have a distribution, you find the mean of that distribution, and if the mean of that distribution is exactly equals to the parameter we are estimating, then that distribution or that statistic is unbiased estimator. Okay, now so we will calculate mean of a sampling distribution and we will check it with the parameter. Okay, now what is the parameter here? So what are we trying to estimate? Can you tell me what is the parameter here? We are trying to estimate mu, right? So let's find mu. Okay, how do we find mu? So mu is mean, right? We know mu is mean. And what is the next name for mean? It is expected value of x. So this is expected value of x. Now, which table do we use? Which distribution do we use to find mu here? First, second, or third table? First, we find the expected value for our from our probability distribution. Okay, so we have this probability distribution, and let's find the expected value. What is the formula? It is summation of x times p of x. So you multiply x with its probability and take a sum. So this is, okay, so let's take x equals to -5. So -5, then you multiply -5 with the corresponding probability 1/9, then you take a sum, plus you take another value of x, which is 0, time the associated probability is 6/9, plus next value of x, 5, time 2/9. So we find the parameter mu from our probability distribution. Does anyone have final answer for this one? And this is 0.556. 0.556. So this is our parameter. Okay, so we want to show x bar is unbiased. So x bar means we are looking at this second distribution. We want to know this distribution x bar is a unbiased estimator. We have the mean of a parameter. Now what do we calculate? We calculate the mean of this distribution. So let's calculate mu of x bar. So mu of x bar. So I have x bar here. Okay, it tells that this is the mean for this distribution. Okay, and it's the same way we calculate our x bar. So this is, if you want to write formula, it would be summation of, instead of x you're going to use x bar, summation of x bar time p of x bar. So let's take each value of x bar and multiply by its probability. Okay, so x bar takes a value -5, so -5 times the probability 1/729, take a sum, plus let's take another value of x bar, -3.33, -3.33, multiply by the probability 18/729, you multiply by this probability, plus let's take another value of x bar, -1.67, -1.67 times the probability 114 divided 729, plus let's take another value of x bar, 0 times probability 288 divided by 729, plus let's take another value of x bar, 1.67 times probability 2 to 8 divided by 7 to 9 plus, let's take another value of x bar, which is 3.33 times the probability 72 divided by 7 to 9 plus, we have one more x bar value, which is 5, multiplied by its probability 5 times 8 over 7 to 9, and the final answer I have here is 0.556. This is what we get. Okay, now what do we know from here? So our mu is a parameter is 0.556, and we did calculate mu of x bar. And what is this mu of x bar? What is the difference between mu and mu of x bar? Mu is a parameter, right? And mu of x bar is a mean of a sampling distribution. Mu is also mean, okay? Both of these are mean. But the difference here is that the mu is the mean of this probability distribution of a population. Okay, this is our parameter. We have mu of x bar. This mu of x bar is the mean for this distribution. This distribution is a sampling distribution. So mu of x bar is a mean of a sampling distribution. And both of these are equals to each other. And if it is the case, what do we call for x bar? Now, is it a unbiased estimator or biased estimator? It is the unbiased estimator. Okay, so if the value of mu, which is 0.556, and mu of x bar, which is also 0.556, are equals to each other, we call x bar as a unbiased estimator. Okay, you will be asked to check whether x statistic is unbiased or not. So you find a parameter and you find the mean of that table, mean of that sampling distribution. If you get equals to each other, if you get parameter equals to sampling distribution of a mean, they are unbiased estimator. If not, they are not unbiased estimator. Okay, any question here? Now, this is so our conclusion is x bar is a, we have to show it. It means these two are, x bar is unbiased estimator, and since the mu is equals to mu of x bar, these two are unbiased estimator. For part B, we are asked to show that m is a biased estimator of mu. So what do we expect here? What will be the mean of this distribution? Will it be equals to 0.556? No, right? It does tell us m is biased estimator. Now let's show it. Okay, so we already have a mu. So what do we need to calculate now for part B? We need to calculate mu of m. Okay, so this is a mean for a sampling distribution of median. So we are finding the mean of this table. Okay, finding mean is very easy. Okay, so here, so the formula would be summation of m times p of m. So let's take each value of m. So we have -5. You multiply by its probability, 25 over 7 to 9, plus you take another value of m, which is 0. 0 times the probability, 612 divided by 7 to 9, plus you take another value of m, which is 5 times 92 divided by 7 to 9, and this is equals to 0.460. The mean of a sampling distribution of a median m is equals to 0.460, which is not equals to our mu. Since mu of m is not equals to mu, we call m as a biased estimator. So it's finding the mean. Okay, So once you have find the mean of a distribution, and if that mean of a distribution is equals to parameter, we call that as a statistic as our unbiased estimator. It has to be equals to each other. And we always use a statistic which is unbiased estimator, okay, to make a estimate of a parameter. Okay, any question up to here? Okay, now let's go to the next example. So we have the same example, okay, so we have same table here, and we are asked to find the standard deviation of a sampling distribution of X bar. Now here we need to find the standard deviation of a sampling distribution of X bar, median M, and we find which statistic would appear to be better estimator of mu. So here, let me give you a hint. I want you to complete, okay, and if you need help, we will do that in our next class. So I want you to find sigma of X bar, okay. So we have this sampling distribution. So you find the standard deviation. Does anyone recall a formula to find the sigma? What is the formula? It is summation of x minus mu squared time p of x, right? So this is the formula for our parameter mu. So what will be the formula for sigma of X bar? It will be summation of, now instead of x, what do we have? X bar. So X bar minus mu of X bar time P of X bar. We are finding the standard deviation for this table, okay? So this table has a variable X bar. So we replace our X by X bar, okay? And the mean of this table, we use mu of X bar. So for this mu, we have mu of X bar. Okay, now let's use this. Okay, now let me show you. Now we take each value of X bar, okay? So we take each value of X bar. So let's take -5. You substitute here, -5 minus, what is mu of X bar? We already know that is 0.556. 0.556 time you multiply by the probability. What is the corresponding probability? For 1/7 to 9. 7 to 9 plus. Now you take another value of X bar, which is -3.33. You subtract with the mean of that table, which is 0.556, and you yes, I forgot to square it, so do not forget to square here. Thank you. And multiply this by the corresponding probability 18/7 to 9 plus. Now let's take another value of X bar, which is -1.67 minus mu of X bar, that is 0.556 square, multiply by probability 114 divided by 7 to 9 plus. Let's take another value of X bar, which is 0 minus mu of X bar, which is 0.556 square it, multiply by its probability 288 divided by 7 to 9 plus. We have another value of X bar, which is 1.67 minus mu of X bar, 0.556. You square it, multiply by its probability 228 divided by 7 to 9 plus. Another value of X bar is 3.33 minus mu of X bar, 0.556 square it, multiply by the probability 7/7 to 9 plus. We have one more, 5 minus mu of X bar, 0.556 square it and multiply by the probability 7 to 9. Okay, this is a lot, but the process should not be difficult, okay? But I'll just make sure that you don't have these values, these many values of X bar on your exam. And I forgot. So this is our variance, right? Not the standard deviation. If we want to find the standard deviation, we have to find the square root. So let me correct here. So this is our variance, okay? Sigma square. And this variance is, it's a lot to calculate. Final answer is 2.675, okay? And the sigma of x bar is square root of 2.675, and this is equals to 1.64. Now, in the similar way, now I want you to calculate sigma square of m. Okay, so find the variance or a standard deviation for our sampling distribution of median m. Now we find the standard deviation for our third table. The formula would be, just I'll write down the formula for you and I want you to complete. So this is summation of, instead of x we have m minus mu of m square times p of m. So I want you to find the variance of the third table, the sampling distribution of mean. Use the same process, but we are using our third table, okay? Use the sampling distribution of median.
And then the probability, or the mean of median, it would be the 4.60.
Yes, so here mu, you are using mu of that table, okay, which is mu of m, and that is 0.460. So this is what we're gonna use. And once you find the standard deviation, so which statistic you're gonna pick? So whichever statistic has a less standard deviation, that will be our good estimator. And if you need help in finding sigma of m, let me know. Find sigma of m. So you find the standard deviation for third table. You are starting. So you are using this table, right? 5 minus mu square divided you have to write it down. You know, but make sure you write all these on your paper as well, okay? So like the way I do. Did you help in finding the standard deviation? Okay. Can you help with finding that is good? Let's see. 95, that's good. Okay, it's good. Can you help? Okay. Here. Yes, so you still have 0 and 5, right? Okay. And the final answer is, so I'll just write down the final answer here for sigma square of m, and that is 3.801. 3.801. So now we need to find sigma of m, which is the square root of 3.801, and this is equals to 1.95. So which one is the best estimator here out of x bar and m? X bar. Why? What are the reasons? X bar is unbiased estimator, and x bar, sampling distribution of x bar has a small standard deviation. Okay, all right, let's do this much for today, and the remaining we'll do in our next class. Do not forget about your quiz and your homework, okay? And I will extend the homework for this section 6.1 and 6.2 until Monday midnight. And so that if you have any question, we can do it on the Monday class.